To revisit the hypotheses on the board. We'll let that thing run a little bit more if you want. You don't even need the normal. That's the beauty. Is the TI has a built-in. The TI has a built-in that takes care of everything you need for you. Now the template is still crucial because the template puts language where the symbols are. For example, at some point, I think it was step 3. Yes, step 3 last time we had that H0 was P. Actually, H1 was P is less than 12%, and H0 was P is greater than or equal to 12%. And in a traditional statistics textbook, that's all they would write. And then send you guys home to have a glass of wine and or a cup of coffee and figure out what the hell that means. So what does it mean? What does this P is good? So go to look at step 1 and 2 on your template. What does P less than 12% mean? What does little p stand for in this case? What does little p stand for? Percent of what? Or percent of probability of those getting the vaccine and got sick. Yes? That's what we gotta make. There's lots of p's floating around this. Lots of p's floating around this course. Yes, little p hat, big P. P value, big P. I like using a capital P for that one. Just so it stands out as different. So little p, which is this guy, I'll make him small. Little p. And we defined in step 2 the probability of getting sick if you're using the vaccine. If the vaccine is working, it should be less than. Now, of course, there's 2 words both starting with S that precede that less than sign, yes? Although we don't say them, they're there, yes? And what are those 2 words? Statistically significantly. Somebody made a comment on the exam. That's the most adverbs I've ever seen in one sentence because you had that one question. It's not necessarily statistically significantly meaningful. It's the most adverbs I've ever seen at once, but you kind of need them. So even though we don't say them all the time, they're implied by that symbol, yes? So this means the vaccine is working. This means the vaccine is not working, right? Vaccine is effective. It's lowering flu rates. Vaccine is ineffective. It's either keeping them the same or, God forbid, making them worse. So the idea is we want a small p-value because this one's bell curve is based around that 12% or higher. We want this one to be down here, less than it. This goes back to your second curve. We want that, of course, as vaccine makers. Unfortunately, we never know if we're right or not. We just want this. We want it down from this guy. Fair? Good. So, how do we make that decision? That, or the hypothesis test, is how we make the decision. Which one do we believe? At the end of the day, it's which one of these 2 do we believe? We're never going to know if we're right or wrong. It's which ones we believe. So that's where you run the test. So, real quick, let's make sure we can run this before we take our 5. And then we'll come back and we'll actually make sure we can run this over and over again using the same setup. So it's in stat, and it's in tests, just like it was before. You're in test as well now. You're at an incident test. Good. We've only run 2 things in this menu so far. We're going to soon pick up new ones almost every day. We've run 1 prop z int and t interval. 1 prop z int and t interval. Those are for the confidence intervals. The one we need now is this guy right here. 1 prop z test. 1 prop z test. And he should look familiar. Some of the prompts, when you grab him, the number 5, when you grab him, oh, it's still set up from last time. I still have the same numbers in it from last time. P0 up there in the top. Why does the TI do this? I don't know. What they mean is H0, what is P? So in this is why I make you write the hypotheses down. You put whatever number you're putting here, you put there. So when you see P0, what they're asking you to do is, please, if you will, place in the decimal you're using in your hypotheses. So one of the reasons I make you write it down on the template is so you know what number to use. If that's fair. Because what students will sometimes do, and this is perfectly understandable when you're learning how to do it, is they'll put 0.101 in there, yes? Because that's the percentage you got from your sample, 10.1%. And they'll inadvertently put 10.1% in there. It's the population. The null is the percentage that's known from the population. Why? Because that's how we set our tests up. So that's why I make you write this down in that step 3. Whatever number you have, you place over there into that null. Is that okay? Ask me questions that is not. Make sure it's okay. Go, Jolene.
Is this signage?
We'll get to that. Let's just do one step at a time if you don't mind. Is this okay right now? Tell me if it's not. Please, go. Kendra, yes,
I'm
go.
still a little bit confused about why you used 12 instead of 10, because
Not a
I thought we
problem.
were checking for our results, and that's the average. Or the
Exactly correct. We're trying to see if our results fit on the population's curve or not. And the population's curve is centered at 12%. That's a great question, Kendra.
So it's always the percentage then?
It's the percentage that's given from the population, right? From the population, the known value. Kendra, that's an awesome question. And the reason we're putting 12 in there is because that has to be the static fixed quantity. Think about it this way. If you ran the study again with a new 1,000 people, the 12 wouldn't change. But your sample results probably would, based on what you're seeing right now, yes?
Where our results are on this information.
Right here, sister. That's our results.
Ah.
That's our results right there. You're one step ahead, my friend. This is where our results live, right here. You put in your sample size and how many of you got sick. And this would change from study to study, wouldn't it? Even if you grabbed 1,000 more people, it might be 120 one time, it might be 98 one time, it might be 5 one time. In the case of the polio vaccine, that's exactly what happened with Jonas Salk. I mean, you basically eradicated. Holy crap. Worked really well.
Dude, polio's back.
Well, hang on now. We'll study that as well. It makes me sad. Makes me happy that Max is eating cat turds too. I don't know what I did with polio, but polio's back. That's not what I wanted to hear this morning. Thank you.
Sorry.
It's all good. Now, Jolene asked a question about the sign. Because there's only one thing left to put.
And is the sample?
Yeah, sample size and the number that got whatever you're studying. In this case, the flu. Goes back. Great. It's in again. This is the only thing that throws students for a loop, I think, is what you put here. You have 3 choices. We're going to look at each one of the choices today in the test we run. The first is does not equal, less than, or greater than. And again, this is why I have you write down the hypotheses in step 3. I want you to be able to just pick that sign up and drop it into your calculator. It's whatever sign you use here,
Which is provided from our study.
which is provided for whatever you're trying to test. In this case, we're trying to make sure the vaccine works, which means it's lowering flu rates. Now you have to kind of think like a TI here, which means go back to the 80s,
So
think Pac-Man, Lycra, and neon colors. You're testing whether or not your proportion is less than whatever number is indicated in P0, which is 0.212. I know, but it's simply what you have written right here. So make this sign match this sign. That's all. That's why I make you write down step 3, so you can pull the sign out and put it where it needs to be. Because if you get the sign wrong, if the sign backwards, you get exactly the opposite result you're looking for in some cases. And that's bad. What you've then done is you've supported the null hypothesis when you shouldn't have. So we'll come back to that too. Ways to be wrong. Now you got 2 choices. These last ones is calculate or draw. I like drawing personally. If you go to the draw option, it gives you 2 things, both of which you need. Oh, turned off. So if you arrow down and then go over to draw and just hit enter, what it'll do is it'll actually, oh, hang on a second. I got a bunch of crap turned off from last classes. Clear off. Sorry. Draw, here it comes your bell curve. Little bit of area out there. Negative 1.8489. That was our test statistic we had last time, right? And the p-value, actually it's close to 3.22. I thought it'd be larger. Which means Excel's centering on something a little bit larger.
My other side's all shaded in.
You picked the wrong sign, didn't you? That's okay. Di, I can predict what you did.
And then we can draw, right?
We can. We just did that, actually. What you did was down here, look where I'm at. You picked that one instead. Watch. Tail. And you got double the p-value. 6.45%. Sometimes we like 2-tailed tests. We'll come into that. We'll take a look at that momentarily. Please.
I don't understand why you picked the less than for this one.
It's whatever you're testing in your research hypothesis. You're trying to see if the flu vaccine is working, which means we're trying to see if the flu vaccine results in lower than 12% flu rates.
So that zero doesn't have anything to do with.
This zero is the null. It's the null it's the same zero that's in this hypothesis here. I apologize for this. The TI is kind of crappy when it comes to its notation. It created the P sub zero. What they mean is, this is P sub zero, this right here.
Yeah,
This guy, both of these guys are P sub zero.
okay.
So essentially, what you're telling it right here Ola, is you're saying less than P sub zero. That's why that guy right there.
So why do we choose, because we want to know the research hypothesis?
Yes, because that's what we're testing. We're trying to see if we're on the null curve, but our research hypothesis, our hope, is the flu vaccine is working.
Okay.
And if the p-value comes in small, it looks like it might be working. Or at least it's what a second look is what the idea is. Does that make sense? I understand the frustration and the confusion that you're feeling at this point. Because I remember sitting in my classroom 20 years ago thinking the same thing. What the hell? It's backwards. It seems backwards. But it has to be backwards. Because the curve you know is the null curve, the 12% curve. You know where that one is. You don't know where the vaccines curve is. So you're trying to see if we can somehow get it off of the null curve. It's more likely that it's on some other curve. And what does off of the null curve mean?
Less than 5/6.
We get a small p-value, generally less than 5%. That means you're probably off the null curve and looking at some other curve. That's the idea. That's the big idea anyway. Does that make sense?
Yeah.
Please keep asking these questions. Actually, right now, think of some, because let's take 5. We've gone 5 over, I apologize. Think of some more questions, and we'll run some more tests.
Okay.
Yes, more
I
questions.
have a question.
Yes.
I can't
Let me turn this off.
remember